Let's get rolling on lesson one, scatter plots. This is chapter 9. We're doing data displays and focus on scatter plots. So it's basically graphing. You guys are pretty good at that, and it shouldn't cause you too much trouble. The tricky part, I guess, now is just using some vocabulary to then describe the relationship between the variables in the graph. We will see, here you see an example where it's talking about positive slope and negative slope. Well, now we're going to be seeing what that means in a certain relationship. And I have some examples to show you to get us started. I scoured the internet for like 1 to 2 minutes looking for these. So here they are for you, and I hope they help you understand where we're headed today. We're doing bivariate data, just like bicycle has 2 wheels, bivariate has 2 variables. All right. And the variables are related in some way most of the time, but sometimes they're not related at all, or there's seemingly no relationship between them. So we'll do an example of a couple of them. So how do you think the amount of time you study affects your grade? All right, so there's bivariate data. So we have 2 variables that both include numbers, or both talk about numbers. So we have the amount of time, and we're saying, how does that affect your grade? All right, the red is your independent variable, the green is your dependent variable. And now, how do you think? Would you agree that the more time you spend studying, the better your grade will be? Now, sometimes on a simple subject that might not be true, but overall, in general, you think as the amount of time increases of studying, your grade would also increase. So what does that look like if you were to collect data and then display it on a graph? All right, here's an example. So you see the independent variable goes here on the x-axis, and then the thing that's affected, the grade, goes here on the y-axis. And each point represents, for instance, like this point would be someone who studied for about a half an hour and got a little above a 50. So that represents one person. Okay, this dot represents somebody who studied for an hour and got a little above a 60. Now this person studied for over 6 hours, 6.5 hours about, and they almost got 100. Wow, that's a lot of studying for almost 100. Anyway, okay, but in general, you see this pattern here, right? As we move left to right, as we go to the right, so the time's increasing, what happens to the dots? They get higher and higher. So the grade is increasing. All right, so as we move to the right, the dots get higher. So that shows an increasing relationship. Now, do these fall in about a straight line? Kind of. There's a little zigzag, but in general, it looks linear. So a linear relationship, a linear increasing relationship. All right, now let's ask another question. How do you think the temperature affects the number of customers at the ice cream shop? As the temperature rises, as it gets hotter and hotter and hotter, what happens to the number of customers at an ice cream shop? What do you think? Do you think the customers increase? Do you think it decreases? So as the temperature increases, as it gets hotter, you'd think, there'd be more people looking for some ice cream to cool them down. So as the temperature increases, the customers increase. So it'd be similar to the last graph where we have 2 increases. The relationship between the 2 variables is increasing. All right, and we see that as the temperature is the independent variable. That's what's affecting the customers, at least in theory. Okay, as that goes to the right, as that increases and gets higher and hotter, the number of customers looks like it increases as well because the dots get higher as they move further right. Okay, and again, it looks to be somewhat linear here as well. Now you see this kind of doesn't really fit the pattern. Why, when it was this cold, would there be that many customers? One thing I can think of is when I walk by during the first day of spring, when I walk by Rita's and there's that enormous line. It's not always a nice day, but what are they doing? They're giving out free water ice. So possibly, that first day that the ice cream shop is open, everybody's super excited and wants their first ice cream of the season, so maybe that's why there's a little spike there. That's why it's a little higher. But anyway, just some things to think about as we kind of try to analyze data on graphs. These are all scatter plots that I'm showing you. They're showing bivariate data, and they are trying to see if there's a relationship between the two variables that have been measured. How do you think the number of customers at a donut shop affects the number of donuts sold? So if I were to say the more customers at the donut shop, how would you finish that statement? Would you say the more donuts would be sold, or fewer donuts would be sold? Okay. Uh, more customers means more donuts, or more customers mean less donuts sold? Or more customers, you'll always sell the same amount. There's no increase or decrease. What do you think? I would think there'd be an increase of donuts sold as the customers increase, let's say. Okay, so this is more scattered than I expected it to be. But you can, in general, see a trend of the more customers, the more donuts sold. You see the number of customers is your independent variable. The donuts being sold here is your dependent variable. That's what's being affected. Okay, so more customers generally means more donuts sold. I don't know why that's like 10 customers, but wow, they sold a ton of donuts. Maybe somebody was really hungry, or maybe there's a big party that somebody came in and bought a ton of donuts for. Anyway, but in general, you can see a trend, a positive trend here, where as customers increase, the dots get higher, meaning the donuts also increase. All right, one last one. How do you think the last digit of someone's phone number affects their quiz grade? Interesting. The other ones seemed to be related, had variables that seemed to be related in some way, and kind of maybe a little more obvious way. But what do you think the relationship is here? As the last digit of someone's phone number increases, what happens to their quiz grade? What happens to the quiz grades of those people? If you have a higher digit in your phone number, do you think you're going to also have a higher quiz grade? If you're thinking, that doesn't even make sense, Mr. Woodworth, how would the last digit of my phone number affect my quiz grade? You'd be right, because check out the data. All right, here is the graph, and we have the last digit. Digit is on the bottom here, last digit, and we're seeing if that affects someone's score. And you see there's no recognizable trend here. There's no grouping of the dots. There's no line that they all kind of follow. They're all just scattered. So there's no relationship. The last digit of your phone number typically isn't going to affect how well you do on your quiz. All right, so that is our quick introduction. I hope that helped you understand where we're headed with scatter plots and bivariate data. Enjoy. I hope you're enjoying the beautiful weather today, and I'm sure you're all looking forward to June. All right, peace.